Hello, welcome to StreetPixel. In this video, we are going to discuss about ambient occlusion in Arnold and Maya. Now, this is a scene I have downloaded from blenderboom.com, and this is a very potential scene which I felt can be very useful to explaining this particular video. Now, this particular scene has, you can see, a different kind of a rough surface over here in this candle. This candle and this cup is a smooth surface, and these two skulls are having curvatures and as well as a very complex surface details. So this particular scene is going to help us to understand how the ambient occlusion actually works. So now let's discuss what is the ambient occlusion itself. If you already know, that's fine. Otherwise, I'm just explaining this. Now, ambient occlusion actually helps us to create a contact shade between two surfaces. Now, contact shades actually depending on how close the two surfaces are. Now, you can see the contact area of the skull and the base plane is way too darker than the contact area of this candle and this skull. Or you can see a very distinct amount of a depth that can be seen on the self surface. The shades are visible in this particular candle, because this candle surface is quite rough. And so how this ambient occlusion actually been calculated, which with my understanding of ambient occlusion, it depends on the between the angles of two different surface normals or directions. Like if there is one surface something like this and another surface something like this, so this area will create a particular shade for both the surfaces. Now, it's not about only the distance. I believe it's about the angle between the two surfaces. Like let's suppose one surface is in this direction and another one is another angle is on this direction, and in between this, the angle of the surface, in between angle of this particular surface, I think it's really weird. Okay, yeah, so it's a one black and the other one maybe red. Yeah, so the angle between these two surfaces actually very important. Now that creates that determines the amount of shades that area will gonna create. Now, if the angle is way bigger, which is almost kind of a near to the 180 degrees, or even more than that, like this obtuse angle, if I'm not wrong, what I guess so. I'm not very good at math, so I cannot recall the exact angle. But yeah, it's the bigger the angle is, the shade will be way less. The smaller the angle, it will create a darker shadow, which I understood by going through the ambient occlusion scenes and all. So yeah, so let's see how Arnold ambient occlusion can be calculated, and and how we can control the shader. So I've already taken an ambient occlusion shader from Arnold's shading list, this ambient occlusion, and this is still in a very default values, so you don't have to worry about whatever the changes that I have made on the first scene. So this is a default value that you're actually looking at. And the first option, that is called samples. Now samples are actually, it's a very universal thing in Maya, where wherever you see samples, that means this will increasing of the samples will incur two things. One is it will increase your quality of your render output, as well as it will increase the render time. Now, as I'm saying that this will increase the quality of your render output is not always true, because sometimes after reaching certain threshold level, you actually cannot see, or it's the quality improvement is not at all visible. It's just a render time which is it's taking. So it's very tricky, and you just cannot pump it up to a certain level where you really don't require it to. So for this ambient occlusion specifically, I would ask you to to use these samples to reduce the noises that you can see in your ambient occlusion area. Like, let's suppose 4, hit 4, and that will reduce the noise. I'll just take a snapshot of this particular thing, render, and then I'll just pump it to, let's suppose, 6. And okay, this is my last render, and this is the current render. You can see there how much the noise has been reduced. Let's pump it a little more, let's suppose 13 maybe, way up, almost double. It will take some time to render, and when the render has been finished, we'll see that the render output will be definitely a way more smoother. Okay, so now you can see, if I select this one, this is a last render which is on 6, and this one is which 13. So this is where the samples comes to play. Now the render time is completely depending on your hardware capacity, but still I would recommend you to use it very carefully whenever you are very much satisfied that yes, right now I cannot do anything else rather than removing my grains. So I'll just pulling it back to my old value, which is 3, because there is nothing to show with this particular sample. Now the next one is a spread. Now this is a very interesting one, the spread one. If you reduce the spreadness of your ambient occlusion, you can see the darkness is getting way more harder rather than softening up, which was earlier. If you can reduce furthermore to like 0.2, 0.1, you will get a very hard edged contact shades, which is not required actually, but there are some times where we can use this in a very dramatic way by changing the color of this black, now which is over here. If I change it to blue, you can see, or maybe red, or maybe white, yellow, or green. Now why I'm saying this, you can take this up and comp it with another with your another render, and use the layer compositing system, like using screen method, or sorry, overlay. You can have a very unique stylization of your render, but again it can be very tricky which color you are using, and you have to be very perfect where you about your color choices and all. But yes, if you pump down to the spread value to absolutely 0, then you can see it's a very unique stylization that we actually can get, like some 2D renders and all. This is also can be achieved by this particular spread value. So, but if you are going to use a very typical ambient occlusion method, I would rather suggest to go to 0.6 0.75, it might be the ideal sorry, 0.75. 0.75 will be a very ideal to start with your renders. Now next comes the Falloff. The Falloff is a very self-explanatory about this ambient occlusion. So how fast this particular this shade will fade out. Now if we increase to by just dragging this slider, you can see immediately, I mean, we haven't just merely touched it, and immediately we started losing the blackness out, except where two surfaces are absolutely close, at the bottom of these candles, at the bottom of or bottom of this skulls. But you can see the eye sockets, the contact, the other areas, like this particular candle's surface, which was very rough and bumpy, has lost its details. Now this is something where we have to be very careful, that how quickly we want this Falloff to happen. So I'll just press Control and click and drag over here by gradually increasing the number, like 0.1 or maybe 0.2 or something like that. And if we are happy with it, then it's fine. Otherwise I can reduce it to 0.08, 0.075 maybe. Yeah, I like 0.75s. And you just pump up this spreadness to 1, which will a little bit compensate of these two. Okay, and that's how the Falloff works. But right now I'm just pulling it down to 0. Now the next two options, though it's very common thing for a camera, like near clip and far clip, but these things is something which really can help you to get a very interesting results. Like near clip is how close the ambient occlusion will start to calculate, so I'm just going back to this one. Just let me let me explain you this one. This is a very interesting one. And yeah, so let's suppose the two surfaces are like very close. Okay, now this is, let's suppose 0.1, 0.1, and this is something like 10, let's suppose. These are the two distance. Now my threshold level near clip, if I said 0.01 to 10, this is the range that will going to be calculated. Now if I want my range to be 5 to 10, then this sort of surfaces which are close to each other will give you a very weird result, and almost kind of an opposite one. Let's see how it actually works. So right now my near clip value is 0 and the far clip value is 100. So let's first reduce the far clip value to, let's suppose, 10. You won't see that much of a difference because almost none is matching that particular threshold. Let's suppose so now immediately you see that you started losing some of the white areas. Now let's go back to 10, and I'm just deleting the old snapshot. And so start with the 10. Just remember this one is a 10. Now let's go to 3. Sorry, 3, and then hit again. Say so now the first is this one, which was having the far cliff of 10, and this one you can see immediately the loss of the details. So this one and this one is actually two different threshold of your far clip. Now this is really interesting. What if I go back to my far clip of 10 and I will increase my near clip value to 5. You can see a very unusual results which is coming out. Let's delete this one so that I should not accidentally click on them. So near clip value, let's suppose I'm just put it 1, and you can see the area which is close to that particular surface, like the contact areas, has become white. Now why? Because this is beyond my clip threshold. That's why it is not showing in black but showing in white. Now if I change the value, if I change the value of my black to a different color like red, now you can see more clearly that your contact portions are absolutely out of your occlusion calculation. Now this is something which you again can use to create certain innovative way of colorization of your particular scene. Now this is also very interesting. You can compose it with your scene to tell a very different kind of a mood or different kind of a different way of storytelling. This is going to help you out a lot. So near clip and far clip are really tricky to use. Now I guess you have already get to know about this white and black and white options. This is just the color of what exactly you want the contact parts as. You can just change the entire you can just change the entire black and white. It's reversing it, and you can use this one as a dart pass also. I have seen certain people using this method and creating a dart pass by inversing this particular two values and take up this one as a dart pass. Okay, so cool. Next, let's come to the invert normals. Now, what is the invert normals it's just it's going to calculate in the different direction of the surface normal. Right now, all the surface normals are on the outside, so that's why it's not going to show us. So I haven't honestly found any specific use of this particular this particular option, but the self only, I can show you one thing which maybe for you makes sense. Okay, so I'm just create one. Okay, created one object, and now you can see that somehow this particular object is also calculating a particular level of ambient occlusion, now which I might not want to happen. Now what will happen if the self only options on? See, this thing is really interesting. Now I can, okay, now I have two objects. One is an entire a set of these models, and another one is the plane. Now two things are having the same ambient occlusion, but sharing the same ambient occlusion shader, but not this one. So what will happen is, if I use the self only option, you can see immediately this particular object is getting almost excluded from the effect of the ambient occlusion shader. Now here, if I select this object and hit self only, again you can see that object is not being made into calculation. So the contact shades are not being calculated over here. This is only the surface itself making this angle with the surface with its own surface is going to calculate the ambient occlusion, not with another object. So the contact shade between two different objects has been excluded from this calculation. So I don't know whether I'm being very clear about this. So let's take this one into okay. So there are two options. One is the two ways of calculating this. One is one object, another object. Okay, and another one is within an object there are two different normal directions. Okay, now this will also create some ambient occlusion over here, and this one also create an ambient occlusion over here. Now when you said self, I'm sorry about my handwriting. So when you say self only, it will calculate only this kind of ambient occlusion, not two different objects like A and B. It will only calculate the ambient occlusion of the same surface within that surface, and that's why exactly what is happening over here when we are using self only. It only calculating the self ambient occlusion, but not with the other. Now, this is something really interesting, and this can help you out when you having a very different three different kind of an object. Now if I say turn off the self only option, it immediately start calculating the ambient occlusion with the surface. Now you can ask me one thing, why this particular candle is also showing the shade of this skull? Because here is the trick, this object is an one single object, so it is calculating as a one object, and that's why the self shadow or the self surface is calculating this ambient occlusion, and that is the reason. So yeah, hope you enjoy and understand this. Thank you very much. Please subscribe to our YouTube channel and follow us on Facebook and Twitter. Thank you and good day.